to build the group table, we'll want to first notice a few things, like the fact that rotating through 120 degrees once and then twice is the same as if we rotate through 240 degrees one time. And so we can start making those sorts of observations. So first, going through a rotation of 120 degrees and following that by another one will give us the rotation through 240 degrees. And obviously, first going through a rotation of 120 degrees and then going through a rotation of 240 degrees puts us right back where we started with, which is no surprise since 120 and 240 are 360, which is equivalent to 0 here. So this rotation is 0. So then this becomes r sub 0 here. And similarly, we can figure that these rotations certainly commute with each other. And so if we first did a rotation of 240, followed that by a rotation of 120, then that's going to give us the identity. So in my Cayley table, the columns are applied first, and then the rows. So that's how I'm building mine. Yours may be built different. People have different ways of doing this. So if I rotate through 240 first, and then I rotate through 240 again, I'm sure you see that what's going to happen to me will be as if I just rotated through 120, which is exactly what this is. So this produces twice at 240 produces a rotation of 120 degrees. Similarly, if I wanted to go through and see what happens if I first, putting back the triangle to the identity now, what happens if I first do a reflection through the 0 degree line? Remember that fixes vertex 1. Then that interchanges vertices 2 and 3. And now, if I do a rotation through 120 degrees, that puts me at the place where vertex 1 went to vertex 2, 2 went to 1, and 3 went to itself. So 3 was fixed, and we interchanged 1 and 2. Remember, that's F3. The other way for me to go through and figure these things out without using this triangle is simply to go through and trace through what happened. If I wanted now to figure out what is F2 followed by R120, so first I'm doing F2 and then I'm doing a rotation through 120 degrees. So first I flip through the line, 120 degree line, and that fixes vertex 2, and it interchanges 1 and 3. And then I do a rotation of 120 degrees. So what you see happens is, at the end here, I see 1 went to 1, 3 went to 2, 2 went to 3. That's the same as F1, where we fixed the vertex 1 and interchanged 2 and 3. So we find that this is F1. Now, another way for us to have done any of these computations is to just take a look to follow to see what happens to the vertices 1, 2, and 3 in our definition of these functions. F2 sends vertex 1 to 3. It sends vertex 2 to itself, you know, and vertex 3 goes to 1. And then R120, that sends vertex 3 to 1. It sends vertex 2 to 3, and it sends vertex 1 to 2. So here's the 1, 3, 2, where you see vertex 1 is fixed, and 2 and 3 are interchanged. And again, that's F1. So instead of me using this triangle, it's perfectly fine for me to just use the definition of these functions. So if I wanted to compute this last element here, first I apply F3, and then I compose that with R120, and I can see what happens to 1, 2, 3 by tracing them through. F3 we know fixes vertex 3, it interchanges 1 and 2, and then R120, it sends vertex 2 to 3, it sends vertex 1 to 2, and it sends vertex 3 to 1. Now, if we look to see what is 3, 2, 1 in our list, we find that that's F2. So R120 composed with F3 is vertex F2. And note that in these rows, all of the elements appear each time once. And that's what has to happen. If you find, in a row and a column, if you find that the elements are appearing in your table more than once in a row or a column after the computation, then you've done something wrong. They do not repeat in this instance. So we can continue going through and looking at the table and building it, either using the triangle or using the definition of our functions. And at the end, the result, I will show you the result.